Hello, our most valued student. My name is Confident. Welcome to our revision of the Mathematics N3 question paper, which was written in November 2020. And we have been looking at the last 5 questions, which is question 1, 2, 3, 4, and 5. And now we are looking at the last question, which is question number 6. So if you haven't seen the previous questions, I will encourage you to grab hold of those, as you will gain some good strategies on how to approach the questions as you prepare for your final exam. So this is a good way of revising, as you can see the way I approach these questions, and you can actually incorporate some of these ideas. Now let us look at question number 6, and we are starting with question 6.1. Now question number 6 usually focuses on trigonometry and all the aspects of trig, and we are going to see how the examiners from that whole section of trigonometry of mathematics N3, what sections did they focus on. Now the first question is 6 marks, and it is saying use basic trigonometric identities to simplify the following. So we have got a lengthy question, which is all that. But now the way it is given, it is confusing if you try to work all of it at the same time. What I advise is to take it section by section. You'll see what I mean by that. And then when you have done everything, you can then now put all the simplified versions and try to simplify it from there. So from here, I'm going to say this is equal to, I will then bring all the simplified versions here, but for now, let me simplify each and every item. The first one I'm having is sin 180 plus x, and for me to do that, I'm going to use the reduction rules, and I cover the reduction rules extensively in my mathematics N3 for the underdogs. So I will assume that you have already gone through that lesson or through those videos that I use, and then through those videos so that you can see the methods that I use to simplify that. So I will assume you already know the reduction rules in detail. So this is then how you must now incorporate those reduction rules to simplify that. Now sin 180 plus theta, you must know that this is third quadrant. 180 plus x is the third quadrant, and in the third quadrant sin is negative, so this becomes sin negative x. So that is the first part. The second part you are having is inside here, which is cos squared 360 minus x. So if I can write it, it's cosec squared. So cosec squared is actually cos 360 minus x. So that I don't confuse you, let me use a different marker. If I say cosec, first let's focus on cosec 360 minus x. This one becomes, now cosec is linked to sine, because cosec is let me just go through the formulas. I think I have them here. Now if I can take you to these some of the trig formulas, it is at the back of your question paper. Now you can see in the first one that cosec and sin theta are linked. So sin is 1 over cosec, which means cosec is 1 over sin. So these two are linked together. So because of that, now cosec and sine or sin, they use the same reduction rules. Now cosec 360 minus x, just like sin, this is the fourth quadrant, and sin is negative, so it becomes negative cosec, not sin actually. You maintain the cosec, it's negative cosec x in that case. Now, because the question says it's a squared, we are going to actually incorporate that to say, therefore, cosec squared 360 minus x, then you will have, in this case, bracket minus, that's how you write it, because this squared, actually you can remove it from there, that cosec squared, and it actually means it is outside like that. That's what it actually means. So you are having minus cosec x, and the squared is outside like that. And then when you have that, now the negative and the negative is a positive, so this becomes a positive because it's minus cosec x, which is positive cosec squared x in a way. So that is how it simplifies. And also, again, I will say therefore, it further means if I say square root of cosec squared, in this case, square root of cosec squared 360 minus x, it says minus 1. This is the same as saying square root of cosec squared x minus a 1. Remember, I'm now focusing on this part which talks about cosec squared 360 minus x minus 1. So if I do that, I will have, this is similar to the formula. There is a formula for that. If I can go to the formulas, and you can see I have where there is cosec. Now let us look at this particular formula. You can see it says 1 plus cot squared theta is equal to cosec squared theta. If I take 1 to jump the sign, it will be cot squared theta is equal to cosec squared theta minus 1. So if you look at this, is what we are now having as cosec squared theta minus 1. In this case, where this theta is x, so which means this is equal to cot squared theta. So I can continue and say this is cot squared x, and you know cot squared x, now the square and the square root will cancel each other, so this becomes cot x in simplified form. So the top one will become cos x. We are simplifying it also further. Now we are looking at the bottom one, which is this part. So we will start by saying tan 360 degrees minus x. As I said, you need to do it in parts. Don't take it all as once, because it usually leads up to some errors. But if you do it in parts like this, this is part of the working, they will mark you correct. Now tan 360 minus x in as reduction rules, this is the fourth quadrant, and tan is negative in the fourth quadrant. So being negative, it is negative tan x, just like we did for cos. Therefore, for sine, cosec, therefore tan squared 360 minus x. If you remember, I said this is same as saying bracket minus tan x, and the square is outside like that. So this square, in a way, is like you've got two of them as, again, minus 10x. That's what it means. So you've got minus 10x minus 10x, and negative and the negative multiplying gives you a positive, and 10x times 10x is 10 squared x. So this is what I was meaning in the previous one for cosec. I'm just showing you the other version of it, or the other way of putting a square is to write it twice. So with that, then it says square root of 1 plus 10 360 minus x. So we have got 1 plus 10 squared, remember there was squared there, 360 minus x in this case, which is because there's a multiplication sign, so the square root only simplifies to that, and then you can then conclude and say this is same as saying square root of 10 squared x, and again like previously, square root and the square will give you your 10x. So this is also how that simplifies. We move on to the other part. There we have cos 360 minus x. If I can also use, these are much simplified. So if I can have cos 360 minus x, is to using your reduction rules. This is the fourth quadrant and cos is positive, so this will simplify to cos x, and the last one is cot 180. Actually, see, there is an error that I made here. There is an error here in the, I'm just seeing some error here. I was quick to notice it because I said 1 plus 10 squared 360 minus x is actually square root of, let's correct that quick before I forget it, it's square root of 1 plus 10 squared x, not just 10 squared x. So it is 1 plus, I'm seeing that when I saw that when I was going back to that question. Now when you have simplified it like that, let's go to the formulas again. You can see that we have this part which says 1 plus, as you can see there, 1 plus 10 squared, 1 plus 10 squared x is theta is equal to sec squared theta. So this is actually sec squared theta. So this is same as saying square root of sec squared theta, and with square root of sec squared theta, this will actually square root and the square, it will give us sec theta in this case. Actually, I'm not supposed to use the word theta there as in the formula. I'm supposed to use our theta in this case. It is our x. So you see that one. So I was correcting from that. Now similarly, we have done the cos 360 minus x, that is correct. The last one is cot 180 in this case. It is cot 180 degrees plus x. Now if you go to your formulas, cot is linked with 10, as you can see in this particular case. It says 10 theta is equal to y over x, which is equal to 1 over cot. So 10 and cot are linked, so the reduction rules of cot is the reduction rules of 10. So which means cot and 10 in the third quadrant, 10 is positive, so is cot positive under the reduction rules. So cot 180 plus x, if it was 10, it was going to be 10x, but because you're dealing with cot, we are also going to maintain it as cot x in this case. So now with all these, you're going, as I said, I put an equal sign here intentionally to say I'm going to write the simplified versions of all that. So the first one, I have my division line here. So the first one was sin 180. So I'll put a bracket and have minus sin x dot, and it was multiplying the next one. It's simplified, which is that part. So this part simplified into that part, which became cot x, and then over, and then the next one, the 10 part, simplified to give us that part of sec x. So I'll go there and have my sec x times the cos, that part was that, which is cos x dot, the last one was this part, which was, that one is cot x. So that's what at the end of the day I was having, and I'm simplifying that to say, if you are to continue with it, cancel out what is common. The cot will cancel out the cot, if I can use that to say cot x, and cot x, it cancels, and then what is left is you can see that this is minus sin x that's what I'm having. I think, yes, it was the negative that, and then it's minus sin x over now sec x and cos x. If you go to the formulas, you can see that it says cos theta is equal to 1 over sec theta. I'm using this particular formula now here. It says cos theta is equal to 1 over sec theta, so actually it will be sec x in this case times, where there is cos is 1 over sec x. I think you can see what's happening now, meaning this again will further cancel with that to give us a 1 and 1, and then the answer will become negative sin x. So you can see now how this become, or this, how this simplified. So the negative sign there is actually showing that the whole thing will become negative. So now if you can look at how the whole question just simplified to minus sine x, it will confuse you, as I said, if you try to write it same time. But what you need to do, you need to split it in parts like what I did, and as you are splitting it in parts, it will actually come out easier and much simplified like that. Now let us move on to the next question. In this case, our next question is question 6.2, and there is a diagram given here. I think it can fit in there. Now the question says, consider the following figure B. So this is figure B, as you can see that. So let's consider this figure, and then it says BAC is equal to 84 degrees, and I think you can see the B, the A, and the C. So this particular angle there is 84 degrees, and angle B is equal to 43 degrees. So this whole angle, in other words, is ABC. Now this whole angle is 43 degrees. AC is 13, so AC is 13, but please take note that they gave your answer in centimeters. So whenever they want you to find the distance, do not forget the units because you'll be penalized, though they didn't include them there. And AD is perpendicular to BC. There is AD being perpendicular, and by perpendicular you can see that 90 degrees is proof of that. Now let us look at the questions that they are bringing under that. Question 6.2.1 is out of 3 marks. It says calculate the length of AB. So they want us to calculate the length of A and B. Now for that, it's 3 marks. One of the easier things or the quick things to notice was you could have found this angle. These are angles in a triangle. Remember, sum of angles in a triangle is 180. So which means if I can say angle A plus angle B plus angle C is equal to 180 degrees, and the reason is sum of angles in a triangle. Remember, they add up to 180. So angle A is 84 degrees plus angle B is 43 degrees plus angle C, which is 180. So to find angle C, it is equal to, you take your calculator and you will subtract now from 180, say minus 84 minus 43. It's 53 degrees. So you know this angle is 53 degrees. So when you have done that, you can then focus on, remember, if this is A, this line BC is small a, and if that is B, the line 13 is the small b, and big C, we have got the small c, like that. Now if you can look at the pairs, you can see that we have got a B and a B, which is a complete pair. So when a side, in this case, when a side and an angle are a pair, you must remember that you can use the sine rule. The sine rule is what we need to use. And if we go to our formulas, and if I can just remove the previous things. Now in our formulas, when we're talking about the sine rule, we are talking about this particular rule here. This rule says sine A over A is equal to sin B over B is equals to sin C over C. So now first, let us look. You can see that the big A has the small a, the big B has the small b, the big C has the small c. So let us look at the one that is complete. We have got the B and the B. So meaning, if I'm to write this formula, I have got that which is complete, which is sin B over B. So I'll write and say sin B over B. You can see where there is sin, where there is B, I'll put the big B is 43 and the small b is 13. So that is complete, is equal to, and I'm supposed to find, remember the question says I must find the length of AB. So you can see that in this case AB is C, so I will link it then with sin C over small c. So that is how this whole thing, or this whole question, could have been answered. Now I now substitute and say sin B is sin 43 over my B, remember, is 13, is equal to sin C or sine C, which is sine 53 degrees all over. Now C is our AB because they want me to find AB. When you have done that, you cross multiply. So when you cross multiply, you are saying AB times or dot sin 43 is equal to 13 times sine 53. Then after that you divide by sine 43 both sides, so that you will then have your AB is equal to, you use a calculator here to say it is 13 times sine 53, remember to close that bracket, over sine 43. When you have done that, then there is your answer, 15,22329. If you are to round off, remember you need to round off to 3 decimal place. You say shift setup and then fix, then to 3 decimal place, which is 15.223. That's the answer there, is 15,223. Remember the question was, in this case, you need to calculate the length, and you can see that they gave our answer in centimeters. Also, you need to retain the centimeters as the units, because if you don't do that, they will penalize you marks. So you have to use the sine rule for you to be able to find that. You have to identify that the sine rule was going to work for you. How to identify? Check for the pairs between the side and the angle, and you will actually now be able to solve the unwanted side or the unwanted angle. But again, if you want to know about the sine rule, check out my videos under mathematics entry for the underdogs, and you'll be able to simplify that. Now moving on, and we're still in 6.2. I think there was another question, 6.2.2. yes, it says now calculate the length of BD. So which means they want the length of that particular side B and D. So now if you still remember what we have, okay, so this is, how many marks was that first before we do that? This one is 3 marks like the previous one, and it wants us to find the length of BD. You had some options here to do. The first part is, remember you already have the side which is AB. From the previous question, AB was 15.223. so if you come here and say this is 15.223, and with that, if I can use this line just to separate this triangle and make it stand out, as you can see, this is a 90 degrees as they have given me. So look at this triangle A, B and D, and we have got our side here as 43 degrees. So with that, I can actually use now, remember SOHCAHTOA, SOHCAHTOA. If it's new to you, it means definitely you need to grab hold of my mathematics entry for the underdogs, just to check how simple I use this. Now with SOHCAHTOA, I have to identify now my sides. And when I'm identifying my sides, BD and angle, which is 43 and 90 degrees, are adjacent. So this is my adjacent side, and this one is my hypotenuse side, and this one is my opposite side. Now the question is interested in the adjacent side, which is BD. So now if you look at SOHCAHTOA here, SO doesn't have A. I need the one with A, so I'll scratch that one. The first one, which has got adjacent, is cos is A over H, which is fine. And the second one, T for 10, is O, opposite over adjacent, but I don't have this opposite side, so this one is also off. So that is what I'm gonna use. So what does it say? It says cos theta is equal to adjacent over hypotenuse. So cos theta, now my cos there is 43 degrees, is equal to my adjacent is my BD over my hypotenuse is the one that I calculated in the previous question, which is 3. And then you can actually this say over 1. Then there is again a cross multiplying, or you can simple multiply by 15.23 both sides. And then when you've done that, you have 1 times BD, which is BD is equal to 15,223 times cos 43. Then your calculator will give you the length of BD. Remember, the units must be in centimeters. So you're going to have 15.223 cos 43 in this case, and then that is that. Remember to round off to 3 decimal places. You say shift setup, there is 6 for fix, and then you say 3 decimal place, which is 11,133. As I said, the units is in centimeters. So in this case, we're using trig ratios to simplify. It was a trig ratio 1. And again, where did I get cos as adjacent over a hypotenuse? If you still go back to this part of the formula, you can still use without SOHCAHTOA. You could have actually used this one to say cos. Let me see if it's there. Unfortunately, you don't have it, which means you definitely need to know the SOHCAHTOA. As I said, grab hold of my mathematics N3 for the underdogs. You'll be able to know that. So that is how you could have gotten your 3 marks on that. Let us move on to the next question. Now 6.3 is our next question, and this particular question was out of 4 marks, and then you're supposed to solve for theta. I say solve for theta if theta is in this region between 0 and 360, and you are given that. Now you can actually solve it at once, but I prefer first, before you simplify it, try to simplify it individually so that you can see what it leads to. For example, using reduction rules, sin 330 is same as sin 330 is in the third quadrant, which is 360 minus 30 degrees. So if you say 360 minus 30 degrees is 330, and in the third quadrant sin is negative, so this is negative sin 30 in this case. So that is the first part. It is negative sin 30. You do the same thing to cos 240. Now 240 is in the third quadrant. The 330 actually is in the fourth quadrant, but the 240 is in the third quadrant. So this is same as cos 180 plus, if you check calculator to say, 240 minus 180 to give you 60 degrees. So it's 180 plus 60 degrees, and in the third quadrant cos is negative, which is negative cos 60. So that is that. Then you move on to cos squared 135, which is 4 there, but you can focus first on cos 135. It is in the first quadrant, the second quadrant, which is cos 180 minus, if you can subtract to get the angle, which is 180 minus 135. You can see it's 45 degrees. Remember, we're using the reduction rules again here. Now cos is negative in the second quadrant, which is negative cos 45, but as I said in the previous one, the square part, which means therefore cos squared 135 is equal to minus cos 45. Everything is squared. Then this is the negative, and the negative will cancel each other, which is same as cos 45 squared. Alright, so now if we go back to the original to say 5 sin theta this will be equal to 2, and then remember this sin 330 reduced to minus sin 30, and then times this cos 240 reduced to negative cos 60 plus 4. Now cos squared 135 reduced to 4 cos 45 and squared times, now sin 90 you just have to use your calculator, and then because 90 is on the region, like it's 0, 90, 180, 270 and 360, you just use your calculator and then you say sin 90 and see what the calculator gives you. It gives a 1, so that is times a 1. So you further simplify and say sin theta. Usually they'll say don't use a calculator in such questions, but some could have actually used a calculator on the right hand side and gotten the a simplified answer, which I believe maybe they wouldn't have penalized you. But now it's always good not to work with the without the calculator. So then let's look at this one, which is sin 30. You can see it's half, so it is 2 times negative 1 over 2, and then times cos 60 again. Say cos 60, it's a half again, so times negative a half plus 4, and then what we have here, you've got cos 45, so the best is to do this and say cos 45 and then close and say squared. You can see it's actually giving you a half, so times 1 over 2. So we have got 5 sin theta is equal to, then you can actually say 2 times negative 1 over 2 times negative 1 over 2 plus 4 into 1 over 2. With that, it is giving me 5 over 2. So after that, to solve for x, we can actually divide by 5 on both sides. So if I'm dividing by 5 on both sides here, I've got sin theta is equal to this 5. Actually, it is 5 over 2 divided by is divided by 5 over 1, which we're going to simply change it from divided by 5 over 1 to times 1 over 5, so that this cancels to say sin theta is equal to 1 over 2. Now I want to show you something that was much quicker, which I believe they were not going to penalize you. You could have actually used a calculator to say once sin 2 sine 330 times cos 240. This is just proving if you're right, plus, and then we have got 4, put a bracket, and then you have got cos 135, close, and then say squared, and then times sine 90, then equal to, let's see where I made an error there, is 2 sine, because it must give us a half, 2 sine 330 is fine, times it's cos 240, which is correct, plus 4. I think the problem might be here because I didn't put a square there. There it is. It's 5 over 2, which is what we got as 5 over 2. So I think since they did not say do not use a calculator, you are allowed to just enter that to give you 5 over 2. But now it is always good to know how are you going to solve it if they said do not use a calculator. Now when you have done that, you can therefore say theta is equal to arc sine 1 over 2, and theta is equal to, so we'll come to arc sine, so shift arc sine 1 over 2, and then it gives me 30 degrees. So theta is equal to 30 degrees, or you can say theta is equal to, and then sine is positive also in the second quadrant, which is 180 plus theta, which is equal to 180 plus our theta, remember, is 30 degrees, which is equal to, in this case, it will be 210. Actually, it's 180 minus, second quadrant is 180 minus theta, sorry about that. Supposed to say 180 minus 30, not plus, because plus is in the third quadrant. So when you do that, then you'll say 180 minus 30, it is theta is equal to 150 degrees. You can even test it and say with a calculator, sin 30, it gives me half, and then I say sine 150, you can see also it gives me half. So these are the two answers for this particular solution, hence it was 4 marks. So that's how you could have approached that. As I said, it was much simpler. You needed not to pass through the stage here. You could have gone from here, you go straight, if I can, from here you could have gone straight to this part and avoided all the working that I was showing here, but I was just doing it so that you can see if they say don't use a calculator, how do you go about it. Now question 6, which is 6.4, it says the function f is defined by f of x is 2 cos x plus 30. Then says 6.4.1, sketch the graph. So there is sketching. Sketch the graph of f of x is that for this domain between x is between 0 and 270, showing the coordinates of all the turning points and the intercept with the axis. Use intervals of 30 degrees. Now for you to sketch this, you don't need to worry much. You are supposed just to use your calculator, and the way to use the calculator that I usually advise, it is for you to in this case to have a table of values here. So you can draw your table of values. Here is how first you need the point. So if you can get this point, then it becomes way easier for you to solve. So let's see how much points can we get through that. They said we must use the intervals of 30 in this case, and I'm hoping, I think that will be enough. Let's check. So remember, the first one is my x values and the other one is my y, or it is my f of x. So whatever case you use, it is fine. Let's call it the y values. They say you start from 0 until 270, but now before I write these, okay, let me actually use those. It's 0, it is 30. Remember they said I must use intervals of 30, so 0, 30, 60, 90, 120, 150, 180, 210, 240, and actually it's perfect, 270. So now with that I need to find the y values, and with the y values I have to use my calculator in this case. Now if I can now use the calculator, you have to go to mode and then you select 3, which is table, which allows you to enter now this particular f of x. Now f of x is 2 cos, then there is a bracket which is alpha, that's how you enter your x, plus 30, that's how you work your problem. Then you press equal sign, you start. They say it start from 0, remember it's 0. In this case you can see says I must start from 0, equal, you press equal sign, then you say end at 270, so you say 270, you say equal sign, and the step they said I must use intervals of 30, so the steps there is equal to 30, you press equal sign. So you're going to have quite a number of different numbers. If I can go through the numbers, 0 is 1,732, you've got 30, 60, 120, 150, 180, 210, 240, 270. Now I will say whenever you're sketching these, just focus on the simplified numbers. Now the first one, 0, we can just estimate it to be 1,7 in this case. So I'm gonna have here 1,7 as an estimate. Now we find the other one, and then 30 is 1, 60 is 0, and then 90 is minus 1. Now 120 is minus 1,7. We can actually ignore that and focus on 90 only as being minus 1. This one we can just leave it out because it has got a lot of decimals. $150 is also simplified, but 180 is also having a decimal, so I'll focus on 150 is minus 2. This we will leave it out. $210 is good, and 240 is good, and 270 is good. So actually from 210 is minus 1, 0, and 1. So I've got minus 1, 0, and 1. So you can see these are the points that I have. I was avoiding points that had a lot of decimals, but so that I can have just simplified points because they are easy to sketch. With the 0, I needed to know where is it cutting the y-axis, hence I just estimated as 1,7. Now it says we need to sketch this graph. So when I'm sketching this graph, I will have again, let's have a different line now. Because x starts from 0 to 270, so I have only the positive x-axis, but on the y-axis I've got the positive and the negative, and the highest negative on the y is minus 2 and the highest positive is 1. So if I can have something like that, and also I have a little bit up because like that, and then it is very important for you to mark that this is your y and this is your x. Very, very important. Now you have to divide your line into equal parts. It is very important for you to do that, and remember the interval is 30, so try to divide it into equal parts so that your diagram whenever you're using your ruler, it is even more important because it will make the points equally spaced. So you have 0, we have 30, we have 60, we have 90, we have 120, we have 150, 180, 210, 240, we end here in 270. So that's the end. And again, the y, you divide it equally, so you will have that as positive 1. You also divide it equally as 1 and 2, but the only part is that these are negative. Now we have to plot our points, and when we are plotting our points, 0 is 1,7. So actually it was forcing me to have my y value as a little bit, which I must extend there. Just to have at least trying to make it as accurate as possible now, because I've already drawn my line. This is much better. So as I said, this was my y values. So if I did well, I was supposed to have my 2 somewhere there. Alright. Alright, so the first one is 1,7. This is the half, so 1,7, the graph was supposed to start somewhere there. And then 30 is 1, you can see there is that, and there is a point there. And 60 is 0, so we have a point on that. 90 is -1, so if you look at that, they will meet at some point there. 120, we said leave it out because it's got a lot of decimals. 150 is -2. If you look at it like that and also look at it like that, there is a point there. 180, we leave it. 210 is a -1. You can look at that and that, we have a point there. And then 240 is a 0 and 270 is a 1, so we have something like that there. So with that, you can now plot your graph. Remember, the aim is to plot it as smooth graph as possible. So it is a graph which is somehow coming in as a curve. Because it is not drawn to scale, it won't be as smooth. But remember, this is a sketch that they want you to come up with. So can actually then correct that part to say that dot line, if it can be somewhere here, you know. So that is that part. And remember, it is ending at 270. So then you need to label it as your f of x. You can continue then to say, remember, your f of x is equal to 2 cos x plus 30. So that is that, or just say f of x. Now the question was, sketch the graph. We have done it. And then showing the coordinates of all turning points. So first thing, we need to know what are the coordinates of the turning points. And the graph is turning at that point. And at that point, it is 150. And you can see 150 goes with -2. That's the first part where this graph is turning. That is the only part actually in this case. There is no other turning point. Then it says the coordinates of all turning points and the intercepts with the axis. Already the intercepts are shown. We have got this intercept being shown. That is where it cut the intercept is a point where the graph cut the x and the y axis. We have got that one being shown. The only one that is not being shown is that one, which you can call it 1,7 in a way. So that is the part that was not showing there. So that is what you need to do to make sure that you get all your answers. Now let us move on to the next question. It says we're still looking at the 6.4, and 6.42 says write down the x coordinate of the point or points at which that is equal to that is 1 mark. So they want the x coordinate, just the x values, not the y values. So write down the x coordinate of the point. If it's 1, it's okay, but if it's more than 1, write all the points at which this is equal to 1. So now you need definitely to go to your graph to use that. I'll use a different line. For example, I'll use my red line. So they are telling us, if I can just write it down again for you, they are saying here 2 cos x plus 30 degrees is now equal to 1. Now that's what they're telling us. And if you look at the original equation actually says 2 cos x plus 30 degrees. This was our f of x. So in other ways, these two, they match on the left hand side. Therefore it means f of x here is also equal to 1. So you're going to go back here. Remember, f of x is same as saying y-axis. So these are the y-axis, so y is equal to 1. So where is y equal to 1? You got your line. You can see y is equal to 1 there. You can just, that is where y is equal to 1. Remember, it is not drawn to scale, that's why it is like that. It is supposed to pass through those points. As you can see, I'm making them bigger, and those points. So this is the part they are looking for, that and that part. So the question is, write down the x coordinate, only the x values of the point or points at which this is equal to 1. So the x coordinate, now the x coordinate, you can see here, x here is 30 and x here was 270. So you are supposed to say here x is equal to 30 and x is equal to 270. That's how you could have written this answer. So 6.4.2 is x is equal to 30 degrees, you get a mark, and x is equal to 270 degrees, you get a half a mark for that. So this is how you are supposed to then use that graph to solve the next question. Now you can see that this was out of 21, meaning it is the end of question 6, and at the same time you can see that they are now telling us the total, to say the total is 100, meaning this is the end of the question paper for mathematics N3 out of 100 marks. Now I will encourage you to grab hold of my mathematics N3 for the underdog textbook, which already comes with videos, and these videos make it easier for you to understand even without the teacher, because what I do is I explain in detail each and every part of the curriculum for mathematics N3 as well. There are also videos for previous papers, many of them of the last years, I think since 2018, so that you can actually go through these and see how you can gain strategies on solving them. Now try to get hold of these, and you won't regret it. And I wish you all the best for your preparation for your mathematics N3 exams. Thank you.